Okay. Okay, let us start. Let us resume. Thank you so much for those who interacted. It was really nice to interact with all of you. And if you are facing any internet issue, once again, uh, I I invite you to connect with me later on also. Whenever you feel convenient, you can contact me to learn anything. So problems and solutions. Since you did not come out with your problems, I have narrated three examples earlier, which relates to common day problem. So during half an hour or so, we will be talking about a little bit of applications, how you can use level, what informations you can get, and after the tea break, I will straight away go to the technical aspect of the instruments, which is not very difficult. It's very easy instrument. Easiest, in fact, is the basic instrument in lens surveying, which you can understand. But relating to the relating to routine work, what you do is more important. So let me just show you one thing. Basic principles of auto level we will talk later on. The average height of the ocean relative to land is the mean sea level. Why we say mean sea level? Because water, it is level. Water level we are using every day in the construction activity, right? Just to check the level, we not every time we are using the auto level. We are using the water level. Water level because it remains in the same level. Relative level from the mean sea level is reduced level. Yesterday, I had given you the example of New Delhi railway station where the level was mentioned 214 point something. So it is basically relative level to the mean sea level. So why mean sea level? Than anything else? Because any liquid, and we know how much liquid is there on the entire Earth. The liquid is always remains in level ground, right? You keep the water at a higher surface, it will flow to the lower level, right? So this is the basic uh, uh, tradition, and this is the basic principle of any liquid. So it will flow, it will remain in level. Since the entire have so much of water on the earth, almost 7% is filled with water, oceans and all. So that is the reference state from the mean sea level. Why? Because measure the time of the holistic approach to the project. The authorities, all the contractors, all the consultants, if it is made mandatory, every level will be related to the mean sea level, which is a reduced level, then the problem will be minimized. About our own project, it's a smaller area. So in a smaller area, it is very easy. It is cost saving also to do the local survey. However, no issues which we may face. So make it a point in your practice, as far as leveling data is concerned, please ask your team, please ask your contractors or the consultant if they are doing the survey project for you to always give you level relative to the sea level. Okay. Now, above the sea level, once again, I'm trying to explain you the sea is this. You can see if we are going above it on the mountains, this is 4,000, 8,000, and keep going like that. And if you go below, it has to definitely be negative. So the reference is what? This is reference line. This is a beautiful picture. I like it because you see the level is here on the sea, and below minus and above plus. Above it is showing the mountains and below the subsurface area. I hope it's very clear. It's not very difficult. So why I'm doing time and again so that you can remember it, that every level has to be in reference to the mean sea level, not a hypothetical level. And you can very well see it. Every railway station, as I mentioned yesterday, the mean sea level is written. So in your area, wherever you are working, maybe you can check with the nearest railway station. On the platform number 1, you will find mean sea level is written. So at least you have some comparative idea when leveling data comes to you of your town. For example, Delhi 214. Now there is hardly much undulation in Delhi. It is almost plain, but still in your local area, you can visualize that from the nearest railway station, am I sitting at the level plus related to the railway station or level minus below railway station? So you have some fair idea. Once the data comes to you, you can make it very clear. Suppose your level is in the range of 300 and the data which is coming to you is in the range of 100. You can straight away say plain area that this data is wrong. How is it possible to have 200-meter difference? However, in terms of hilly areas, yes, the level will keep on changing. Maybe it could be your homework that you keep a note of levels in of different areas. Maybe and you maybe and note of the levels at that area so that the you can very easily see the difference. If you see the Mount Everest, the highest altitude in feet above the sea level, which is 808 meters above sea, the Mount Everest. So how to measure that actually? Only related to the sea level, we do the surveying, reached up to top of the Mount Everest, and we found that the difference is 8,848.86 meters. So this is changing. changes, the whole environmental changes and global warming and all that. So these mean sea level sometimes keep on little bit changing. So that is why this high however, look, it has no impact at all. So what I'm trying out for you to relative level why it is important. Now let's have this example, typical example where the leveling data is very critical and extensively used. Components of the roads, there is surface course, then base and sub base. Generally these typical three layers, PWD friends can understand it very clearly, and other friends also. So now these three levels layers are here. Now as an officer you need to clear the bills of the contractors, or maybe you need to check the quantities volume, or maybe you need to estimate the quantities if you are proposing a particular project, or you may have to have a rough estimate if you are tendering a project, if you are inviting the quotations from the local contractors for a particular road construction. You must have some initial idea of the budgetary costing, and to do that you need the basic information about the leveling. Now think of that example which I gave you earlier, when there was undulation in the road. That undulation cross check was not done, and that is why it was not considered and it remained like that. If you remember my yesterday's example, when I had shown you a tree on the road, that information was maybe not correct initially, and the road alignment was to be changed. If the road alignment was to be changed, the cost got changed, your budget got changed. Similarly, if your level informations are not correct, generally when you construct the road, those who are into designing or you know better, then the slope, the curves, all gradient, all that is maintained. Now to decide all these technical aspects of gradient or the curves, vertical curve, horizontal curve, the topography as well as the level data is very important. Topography will decide the two dimensions of the alignment, whereas the level will decide the actual cost, the real cost of cutting and filling. Now to arrive at cutting and filling cost, until and unless you have the correct data available with you, how will you visualize, how will you calculate the budget even? So if you find, the important point here is, if you find lot of undulation, you must try to send your team for cross checking. Is it because of the negligence of the surveyor, the undulation is more, or is it because of the error in the auto level instrument itself that the undulation is more, or is it the real fact that such undulation exists on the ground? On the contrary to that, if you are finding a data which is very smooth, then again it is a point of alert. If the data is very, very smooth, it is very rare. Maybe maybe the field staff has missed the undulation in between. Maybe they are considering, they are taking the levels at a longer distance. So longer distance data may look smooth. However, the and if you don't consider these things, you will end up very high than the allocated cost of the project. And then has to answer that, why it happened. The contractor will simply say that the ground levels which were given to me as far as DPR is concerned were not accurate. And this has happened many a times in a lot of projects. I have also seen it personally. So to avoid that situation, I believe it is very important for you as an officer, once you receive some data or some DPR, just to cross check the same on the ground for undulations, sudden changes in the levels, or even if it is very smooth, then try to take visit the local area. Maybe you will find some differences. If you don't find such differences, fantastic. Appreciate your team that they have done the excellent job. I'm not saying that surveyors are not doing good job. I'm uh, it, just requesting you for a cross check, because this is the initial stage. Any changes in the initial stage, they are very easy. It is very easy to train a small kid. It is very difficult to train the adults. It is a true fact. So whatever changes are required, they are cost effective at the initial stage. They are very, so this is uh, my advice to you. It is okay. Now, fall and gradient in the drainage pipe. Now, I had given you earlier example drainage, right, in the very first slide. This one. Now, if region could be many, but maybe the one region on the same basis, whereas the ground informations were not correct, how it is going to impact the entire project. And mind it, this is underground. Underground costs are very high, and the stake Vishal ji, Vishal Vishal ji, can you mute yourself? Sorry, I'm waiting for Vishal ji to mute himself. Vishal ji, am I audible? Can you please mute yourself? Excuse me, I need to call the admin. नीरज जी, विशाल जी और सुदर्शन जी प्लीज म्यूट कर दीजिए। म्यूट कर दीजिए, वो अनम्यूट हो गए हैं बाय मिस्टेक। जी, थैंक यू। Similar actions. See, some mistake happened in between by mistake that few participants got unmuted, and there was interruption. So I took the corrective action by calling the admin to cross check the data. Then the damages are very costly. So leveling data, how to visualize that? I have given you so many examples that you can visualize very easily. If the data is very smooth, again it is alarming. If the data is very erratic, then it is alarming too. So it is always good to, so it is always very difficult to, I think the speaker is on somewhere. Answering your Mr. Funsuk, your speaker is on. Hello. Okay. They're in that area, so it is happening. All right. So again, coming back to the same thing that as an authority, I request all of you to take care of the data at the initial stage itself so that the mistake is not converted into blunders. Again, I have taken one more example. So invert level are taken underground, the flow is decided. So these are all design aspects which come into picture on the basis of the cannot do anything. If the input is wrong every day and night, suppose you go uh, somewhere to buy some product, don't pay attention to the quality of what you're buying. Later on, when you start using it, right? Not. Yes, there are chances if you are working in international coordinate system. Yes, to certain extent, I think the software can take care of this problem also. If you're providing the data of a local area, and if they find a big difference, yes, they can reject data. For example, as I mentioned earlier yesterday, that I have another company in collaboration with Singapore, largest survey company, and we do the baseline survey of the internal projects. But the contractor got the coordinate from their consultant, and the consultant got the coordinates from the local surveyor. And what mistake was there? That the entire project was in local system. So we sent that those coordinates to our people in Singapore that okay, these are the local coordinates. Please set up the software and let us start the project. Their software rejected that because they say that this is not the data from India. This is not the data from New Delhi at all, because coordinates are very different. Then I got a call from Singapore that, okay, which coordinate system you use? I said, we got this coordinate from the contractor. Then we did the reverse engineering and find out that the surveyor did the local coordinate survey, which the software rejected. So that was so amazing that if you do such mistakes, yes, softwares can take care of it. They rejected the data. So they finally asked to convert the data in international system. And the moment they converted the coordinate system in international WGS 84, the software started working. Whereas not every software is such capable. So we need to take care of the local data ourselves. No one is going to help us out. So once again, why understand the leveling is important. It is not very important to understand the principle of leveling, how it works, how it is done, though I'm going to talk about it. I'll tell you everything after the tea break. But it is very important for you as officers sitting in the office how to visualize, how to check the data, and how it is going to impact the project at a later stage. So please pay attention to that. Mr. Ajay, Mr. Aj, Mr. Ajay, you are on mute, please. We are on forced break, waiting for Mr. Ajay to mute. Mr. Ajay, can you mute yourself, please? Okay, I think there is disturbance, and we are on the verge of tea break. So I allow you to have an early tea break of 4 minutes, so that this disturbance is not affecting our training. We will resume that. So let's have a break. And those who want to note down my contact detail can do so. Okay, welcome back after tea break. I hope everyone is here. Am I audible?
Yes, sir. Audible, sir.
All right, thank you. Okay, let's get back to the more technical aspect of leveling now. Now you see two instruments I have shown you. Left hand side is the auto level and right hand side is the electronic total station. Why I have included this instrument here? Because I posted this question before the break. When we are talking about the leveling, when we are talking about the level difference, I have given you a lot of examples. Now, this is the example of a high rise monument. How to find out the height of this monument? I just wanted you to uh, realize, can you do this with auto level or not? That was my intention of showing you this picture. Anyone would like to comment on this, that how to find out this height of the monument, and can you use auto level for this purpose or not? Anyone?
No, sir. Auto level is not used to measure the height because of vertical tilting in auto level is not applicable, sir.
Yes, Gurupreet, you are right. I appreciate, yes, because vertical tilting is not possible, but auto level, my second question to you, you are right, your answer is right, but we are using auto level to find out the undulations, right? Level differences. So why can't
Yes,
we
sir.
find this level difference in case of a monument?
But because of the level difference measured by the staff, sir, that
Yes,
up to height of 6 meter or 5 meter, with the help of staff, we can easily measure the elevation. But when the height of any tree or any building, that is only used with the instrument that is use the vertical tilting. So auto level is not used in that type of measurements.
fantastic. Right
Uh,
answer. Absolutely right. You are absolutely right. It is impossible or very difficult to have a leveling staff which is very high. It is very difficult to hold the leveling staff if it is more than 5 meter. It is very difficult to hold the leveling staff stable if the height is more. At the same time, auto level is at your height, right? Human beings are using the auto level, so they can use it say up to say 1.5 meter. So any undulation below that, yes, can be measured. But if it is more than that high, it is impossible. So that is why with this topic, I have kept this slide of total station, that in such cases, in case of tree, for example, as Gurpreet has said, right tree, and in case of any monument, high-rise building, auto level is not the instrument to be used. It has got its own constraints. So that is why this total station is used for such applications. So I thought one question may come up that can we use it for this purpose or not? That is
sir,
why intentionally. Yes. Yes, Gurpreet.
sir, there is another instrument which is called the tilting level. That is used in to measure the height. That is limited height, sir, with the help of
Exactly.
tilting level, sir.
Yeah, that is limited. And tilting level has got its own working principle. Actually, it is not tilting in a real sense. But yes, you are right that for a limited application, only for a limited gradient setting, it can be used, not in all the cases. Yes, right. Thank you for interacting, Gurpreet. It was really nice that
Thank you, sir.
proactively someone someone talked to me during the training. It looks really, it feels nice. Okay, thank you. So let's go ahead with the auto level now. With the auto level, these are the items required for leveling purpose. Of course, on the left hand side, you can see it is the in case of total station and GPS, we use wooden tripod generally because we need more stability. The weight of the instrument is more. and instrument is kept on one station for a very long period. So we don't want any impact of heat. Generally, what happens with the heat, if you are using the aluminum kind of tripod, it may expand, or in the winter it may shrink. So that will disturb the level also. So because the auto level is used just for 1 or 2 minutes on a particular station generally, and the instrument
अच्छा,
weight
70%
is
है आपकी
very minimum, so we
हाँ
use the
कंटेंट, तो यही पूरा मिल गया करने के लिए क्या अभी? बाप रे, ये तो बहुत है। हम देख रहे हैं सलाई भरने के लिए। हाँ, हम भी चेंज कर रहा है। अभी और भी काम है मेरे पास।
Sabir ji, thank you. Okay, so the aluminum tripod is used, which is very handy, and a single instrument, a single person, single surveyor can carry the tripod on the shoulder along with the auto level. Then in between this instrument is auto level, obviously, and on right hand side is the leveling staff. So these are the essential items which are required for leveling. One item which is not shown here is a level which is used with this leveling staff also, but generally it is not shown. It is part of this. So these are the three things which you require. I'll take you through to the different part components, though it is not much required, but since it is uh, practical aspect is missing from this training program, so I have kept it so that at least something is visible to you. So foot screws, again, these 3 foot screws for leveling any survey instrument has got these 3 foot screws. If you see here the compensator check, now compensator check. Why the auto level is called auto level? What is the difference between dumpy level and auto level? This is the basic uh, question which generally very common to be asked. The dumpy level. What is dumpy level? I'm sure most of you must have used the dumpy level also initially in your college days, maybe. The dumpy level is basically an instrument which is always kept horizontal using the foot screws. Okay, if it is not leveled, if there is any vibration, if the ground is not solid, the dumpy level will tilt automatically. It will be out of the level, and the accuracy cannot be maintained because dumpy level or the auto level has to sight the leveling staff in horizontal plane. As Gurpreet mentioned that it cannot move in vertical direction. It has to remain horizontal. Right. This slide you can see it has to remain this horizontal. It cannot move up and down. So if any leveling disturbance is there, definitely it will impact. It will move up and down slightly. So just to avoid that, we have something called compensator. So what is compensator? Let me try to explain you. You see, we use in construction the saw, which is called sahul or sometimes plumb bob. We use it just to check the verticality of the wall. So because it has got a weight and it is attached to the thread, because of the gravitational force of the earth, it will remain vertical, and that is why it is used. It will remain vertical. Okay, same principle is used here in auto level. When we are seeing through this lens, in between there is another lens. That lens is just like your plumb bob or saw, which is hanging on 3 or sometime 4, sometime 2 wires, small wires. It is hanging. You can see maybe in the picture I'm showing you my hand. It is hanging. Since it is hanging, it will always remain vertical, right? However, if there are vibrations on the ground, it will keep on vibrating, it will keep on shaking, just to avoid the shaking of the lens. Otherwise, you cannot take the reading. If it is shaking, 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 you cannot take the reading. Just to avoid it shaking because of the sudden jerks or sudden vibrations or sudden movements on the ground, there are magnets also around that lens which is hanging on the wires. So that magnet will help us to keep it stable. So just to check if the compensator is working or not working, some of the manufacturers, they provide this button also. You just press this and you can see that your reading will move and become stable. This is a cross check of the instrument functionality. If the compensator of the auto level is faulty, it will give you the result worse than dumpy level even. Please understand this. If the compensator of the auto level is not working, it will give you the result worse than the dumpy level even. So it is very dangerous. So always engineers need to check if the compensator is properly working or not. Now in terms of accuracy, if we talk about dumpy level, we know it can give say 1 centimeter accuracy. Some people claim that it can give 5 millimeters also, but I have my own reservations on that. However, in auto levels, yes, generally you get 2 millimeter accuracy, which is very popular. In auto level industry, the 2 millimeter accuracy auto levels are very popular. However, there are auto levels which are much more accurate than 2 millimeters. There are auto levels which can give you the accuracy of 1 millimeter and below 1 millimeter also. Nowadays, in the industry, we have electronic levels also. The life has become very easy for the surveyors. Now, the electronic level, how it works like a camera. It will automatically take the reading from the barcode staff. You need not to read the staff. Yeah. See, in leveling, the biggest mistake happens while reading the staff. The second biggest mistake which happens in leveling is to record the data wrongly. Suppose I am reading 1.575. What I am reading? 1.575. And what I am writing? 1.755. You see, we are reading something because we are reading through the lens and then writing on the diary or on a piece of paper. So while looking at it, we are reading correctly, but while writing, by mistake, we write something else. So there are chances of human errors. And generally in auto level, you will find human errors only while recording the reading. There can't be any other errors. So just to avoid that also, for a very precise survey, nowadays electronic levels are available where you just press one button. It will read the barcode staff because it has got the camera inside, and it will record the reading. There is a memory also. It will record the reading then and there. So there are no human errors, almost negligible. So that is considered as the highest level of accuracy in terms of leveling. So we are sticking towards auto level only, since the discussion was about the accuracies and all that. That is why I explained you. For construction, there are laser levels also, but that's a different industry. That's a construction industry. We are not going to talk about it today. So accuracy, which generally maintained using the auto level, is 2 millimeter or 2.5 millimeter. Then sometimes we use this uh, dial here for rough calculation of angles also. It is in horizontal plane. You can see the graduations. So you can, this is the reference. From this reference, you can measure the angles also if you need for some reference. So there is a 360-degree circle below the body of the water level. Now to move the instrument slowly in the direction of leveling staff, there are slow motion adjustment screws on both the sides. With the slow motion, you can move slowly. Then this is reticule focus ring. What is reticule technically? Basically, there are horizontal and vertical two lines in any survey instrument. So that is known as reticle, where there is a eyepiece, the prism, on that a vertical and horizontal line is marked. So that is your reference to take the reading. The horizontal reference to take the exact correct reading of the leveling staff, and vertical reference is to check if your staff is straight or not, because there is a vertical reference also. So you can guide your person who is holding the staff to maybe shift tilt towards left or right until it is horizontal, because if it is not sorry, vertical, if it is not vertical, it will lead to some errors also while you are recording. Straight. So that is why this vertical circle ring is provided in this. Now bull eye bubble means just a circular bubble in the instrument just to level it, and bubble mirror is also there because when you are taking the reading you can see the bubble also at the same time in the reflecting mirror if it is level. Sometimes what happens, you are taking the reading and level is out, maybe because of some movement on the ground, or maybe some vehicular movement, or maybe you by mistake touch the tripod, so many things. So just before taking the reading, ensure that the level is in center. So that is why this mirror is provided at the eye level. Just see the convenience of the engineer. Before taking the reading, he can see that level is in the center, bubble is in the center. There is a gun sight target also. Just roughly you can use this as you use in the gun, just to sight the leveling staff accurately and quickly. This is the focusing knob. Focusing knob is always bigger size because this is the knob which you are going to use maximum just to focus your learning staff for reading purpose. So these are the parts, uh, just similar to any other survey instrument, nothing special. Yeah. This is another picture showing from other side, but this is not important. Now coming back to the leveling staff. Generally, there are in the market there are different type of leveling staff, better graduated staff, millimeter staffs also available nowadays. As I mentioned, the barcode staff is also there for level. So these are the graduations. I'll explain you maybe, let me see if I have that slide. Yes, I will explain you much better because we are not doing practical. I have few slides where uh, I'll show you how to take the reading. So just remember that this is the uh, slidings where you can increase the height of the staff. So 1, 2, 3, 4, 5. It has got 5 sections. So maybe it is 5 meter staff. Generally, you see 1 meter finishes here. This is 1 meter line, and then it will go. Okay, the leveling staff. Let me just read it for you. A level staff, also called leveling rod, is a graduated wooden or aluminum rod. Wooden is always more accurate because expansion and contraction is less. If you talk about the highest level of accuracy, generally the wooden staffs are used. They are very heavy duty. There are invar staffs also, but nowadays not very popular. So aluminum rod is used to determine the difference in heights between points or heights of points above vertical datum. So what do you mean by vertical datum? As I explained you earlier, the always the reference is taken from the mean sea level, and there are local points, local GTS benchmarks which are established by Survey of India. In India, they generally they are available in PWD offices premises also. They are available in near railway stations as well. So they are very safe. So you can find out the nearest benchmark where the level data is also available. So you can start your survey from that point. So this is that was the data I was talking about. There must be some reference. Staffs are either solid having single piece or 3 meter height, or folding staff 4 meter height or 4 pieces. The least count of the leveling staff is generally 5 mm. As you can see here, each you see this black and then white, then again black, then white, black, white, black, white. So each black or each white is 5 mm. So this is the general least count or the direct least count of most of the leveling staffs. Okay, so 5 mm is the least count. I hope you are taking notes at this moment. You might have some questions if you want to use auto level, if you want to know more about leveling staff or something like that. So question and answer session will come at around 11, oh no, around 12. So you can note your questions. I'll take your questions in that session. So this is all about leveling staff. Now I'll tell you uh, how we are reading it. It is not a rocket science. It is not very difficult. It is just a practice. However, in e-staff, sometimes we make some uh, mistake while reading it. So that's the only thing. That is the only thing which leads to errors as far as leveling is concerned. So make sure that you are reading it correctly. Now, how to read leveling staff? I have included this. Just have a close look. If you are using your mobile, maybe you can try to zoom it, or if you are using laptop, it must be very, very clear. So one black and white divisions of 5 mm. As I explained you that each graduation, white and black is generally 5 mm. So you see, this person is looking at this horizontal plane. Now he is at this level. Here it is 0.1 meter, right? So it is going up to this level. This is 0.2 meter. So between 0.2 and 0.1, this is 0.9 definitely. And now is the estimation. Now it is up to you to have that estimation, or you don't want to apply that estimation. If I see it precisely, I can add 2 millimeters here very easily, because if I see this is, if you are able to see my cursor, this is a line black, this is white, right? It is in between. So you see, if I estimate this 5 millimeters, I am sure that this reading is at here. However, this is at this level which I am showing you right now. If you see this surveyor, this horizontal sky blue color line is exactly at the end of this black line. That means it is in multiple of 5 millimeter only. That is why this gentleman is recording the reading as 0.190 meter here. Okay, so maybe next slide is slightly better to understand. Okay, just see, this is 1 and now it is written here 3. That means up to this point it is 1.3 meter. Very clear. Up to here it is 1.3 meter, and you can see 4 also, right? This is 4. That means this line is 1.4. So this is between these two lines. So this, if it is 1.3, now it is going up. How many? Where you see the pen tip is here. So this is, if it is bottom, 1, 2, 3. So 1.33 and this 5. That is how it is measured. Sometimes it is very confusing. I can understand. When I started reading leveling staffs, I did many mistakes because that's the only thing we can commit mistakes while reading the staff. So whenever I used to train new surveyors on leveling, I used to ask them to take n number of readings, n number of points. We basically marked few points with permanent marker on the staff, and my staff used to write the reading of all those points, and they did initial mistakes, and later on, yes, they were correct. And it is the general practice how we are going to graduate in terms of reading the leveling staff. As I mentioned, it is about your estimation also. How accurate you are estimating between these two black lines or between these two white lines. This is your estimation. So from here it is 5, up to here it is 5. So what is there in between? Suppose you are reading here. So you have to estimate if it is 1 mm, 2 mm, 3 mm or 4 mm. If it is close to upper line, it is 4 mm. If it is very close to this bottom line, it is 1 mm. And in between, you can estimate. So finally, if you want to learn the music, maybe the notes are uh, well defined, right? But sometimes the musicians are playing such a nice music because they have practiced many times, and then they play with the notes. Though it is not mentioned that which sound will come out in combination of different notes, that is why the music composers sometimes they are excellent, because they are using their practice to come out with the best. Similarly, for the surveyors, it is your it is their own practice how they come out with the best possible accuracy, because we are going to avoid the human errors here, and the maximum chances of human errors are there in the leveling estimation. You can control the instrument, you can still check the leveling of the instrument because there is a reflecting mirror there. However, you can still check one more thing, the verticality of the leveling staff, because there is a vertical line also. But you cannot control anything as far as your estimation is concerned. It is you and you only how accurately you assume the reading between two lines. So one catch you can have, first of all, if you get some time, if you get some resources, try to practice yourself. Try to take some, maybe keep one sample of leveling staff in your office with some point marked on that. And if you are you have your own staff for survey, maybe just at random invite any surveyor and ask them, okay, tell me what readings you feel these are. Maybe you can cross check with your uh, prime reading sheet that they are correct or not. Similarly, if you are subcontracting any survey work, you can ask the surveyor to come to your office, and you can apply the same cross check just to ensure that this surveyor who is there in the field is accurate. His estimation is accurate. Otherwise, though there are few checks while doing the survey also, but it is very difficult. Sometime, sorry to say, in fact, I had one particular surveyor who manipulated the data a lot. When I see the symmetry in the data in his survey book, I got confused. How can you have such a symmetry on any road? So I cross-checked that and I found that he was manipulating the data every time, reading plus and minus and come out with the result. So that's not right. So just to avoid that, have some confidence in surveyors and ensure that you have some cross-checks. Otherwise, reading can go haywire. Now, how the data is recorded? It is recorded in the level book sheet. Generally, most of the companies, good companies, they keep the level books, and books. This is one of the um, Excel sheet example. Level books are like that only, where serial numbers are written. Sometime here the chainage is also written, right? Chainage, I hope most of you understand. Like if you do the longitudinal marking on the road, say 0 meter and then 50 meter, then 100 meter, or maybe 0 meter, 20 meter, 0 meter, 10 meter, 20 meter, depends on the project, how you mark the chainage on the ground. So sometimes the chainage is also written here. After that, this is BS. I'll explain you later on. This is backside. Backside readings are mentioned over here in this column. Then we have IS also, intermediate sites. So intermediate sites are readings are mentioned in this column, and then FS foresight. This is the foresight. On this basis, some calculations are done. Instrument height of the instrument is calculated here, and later on it is converted into RL, which is reduced level. Reduced level name is given to the level generally with reference to the mean sea level. So reduced levels are having the datum as mean sea level. In the remarks column also sometime they write these things so that it is very easy to understand. Now you see TBM1. This is temporary benchmark number 1, where the level was 50. So they further did the entire survey, and TBM2 benchmark is 50.98. Okay, they have corrected it up to 2 decimal places. It was 978 precisely. So they have converted it into 50.98. Now, because the actual level was 98, the field level is 0.978. So there was an error of about 2 millimeters. Now, you need to study how to correct the RLs for errors, right? So this is again a typical land surveying activity where the errors are divided in some ratio. There are different principles how to divide the errors among all the points and recalculate the correct uh, TBMs, temporary benchmarks levels. So, so this is all about how we use the auto level. Because this session of half an hour was intense technical, especially for those who have no hands-on experience on leveling instruments or leveling technology. So if you have any question, because later on the final part of the training today, I'll be explaining you how we are doing calculations also a little bit, and how we are using it in the field. So if you have any questions, please ask at this stage. As Gurpreet replied earlier during this session, so I invite all other participants who have not been vocal so far, so that I don't feel alone to be here. So please come with your questions, because it is very important to clear all technical points at this stage, because it is intense technical today, something difficult to visualize in fact. Yes, I'm waiting for your questions. I'm just scrolling your list only. Any difficulty you have faced in past while handling the instrument, or anything specific you want to know where you can use this leveling? You can just go ahead with your queries. I hope I'm audible. I'm inviting your questions, please. Can anyone reply if I'm audible?
Audible, sir.
Because I don't see any interaction. Audible. Okay. So I request you to interact, please. It is always good to take the session towards learning in terms of your area of working. Otherwise, instruments and technologies have got numerous applications. But until and unless we utilize the equipment to our need, it doesn't make sense to us. So if you come out with some of your issues, maybe I can help you how you can take it further in your area. Otherwise, it is all theoretical. And I know, including me, we don't like theories. As mentioned by Gupta sir, that yes, next year onwards it will be all practical, and you can come for practical hands-on experience along with your training programs. That is more important. It is more vocal right now from my side, which is not fair enough. Okay, if there is no question at this stage, so let me go ahead because I'll wrap up the session with lot of talks for last 10-15 minutes, combining all the learnings together which we had yesterday, and maybe the entire compact discussion about the utility of surveying in your field. Okay, datum, because specifically it is important to understand, it is an arbitrary level surface from which the elevations of the points may be referred. So the most easiest and the stable is the sea. So that is why in Indian mean sea level is considered datum of zero elevation. So the zero elevation, I explained this earlier also, that there is a datum reference. So all the levels which are measured from mean sea level, they are reduced levels, and such information is available all over India. Survey of India have established so many points. You can take the survey sheets from Survey of India. Those benchmarks are marked. You can it is on paid basis as far as private consultants are concerned. Maybe for government, it might be free or whatever. So you can get those values, and it is important to have the values of such benchmarks, and to know the location of such benchmarks in advance in the area where you are working. So whatever territory you have got assigned, please ensure that you have all the survey data references, you have all the values, complete informations are available to you. So whenever you assign any contract, maybe you have to provide that reference value to the local survey consultant, or maybe to your team who is working in that area. That way your life will be easy, because you are controlling that territory on the basis of the known datum level. Otherwise it may not be very accurate. Again, the localized survey is important. At the same time, having it connected to the surroundings areas is equally important, because your project success depends on the other areas as well, and sometimes we do not consider that. So it's important to consider such information in advance, so that you don't have surprises in the project. Again, this is theoretical. I have already explained you. I'll just read it out for your reference. Elevation or reduced level, it is the height or depth of any point above or below any datum. It is denoted as RL. And the datum could be anything. However, if you are in good practice, have the same datum for all the projects, and datum to be taken as national datum, the points which are established by Survey of India or PWD also have got datums. So please consider those datums. Don't ignore that whatever local data is available with you, your work can be done. Yes, your work can be done. But what about connecting that work to the surroundings? That area, if they are not in sync with that, it will never work. So if there is disturbance in Ladakh for internet, I'm sure it is disturbing our training also. We may feel that, I may feel that, yes, I have imparted the training, but the receiver has not received the training because of certain limitations due to internet connectivity. So similarly, in your project, maybe you can ensure that, yes, I have done excellent project. My every information is correct. But what about the surrounding areas? It is going to impact your project. Your project within your territory is fine, perfect. But your, for example, your drainage disposal may be passing through some other areas. Your drainage disposal may not be in your control. And if you do not have that information, how your project is going to be successful? And it happens many a times. I'll tell you, it happens many a times, because any contractor, any consultant, they consider the project within the territory. They do not go beyond that, because they feel that it is not in their scope of work. Even then, what happens if you go beyond? If you can educate the other person that yes, it is mandatory and why it is mandatory. So time and again, I'm requesting all of you that, considering your project not within your own territory, it has to go beyond. Gurpreet, you want to say something?
Yes, sir. Sir, actually, you share the Ladakh region. You tell about the Ladakh region. Actually, I am also posted at right now Ladakh, and I overseen that project package 3 and package 4. That is Kargil Janskar Road, and it
Okay.
is related to my project. That's why I share my view. Want to share up my view because of there is a number of problems created to take up the benchmarks and whatever to use the topo level, and
Right.
it is related to the my project, that is Kargil Janskar Road. There is a huge problem.
Hmm.
Basically, first is the problem to establish the benchmark or TBM and PBM over there, sir.
Right.
Because all national highway, that NS 301 going in the vicinity of Suru River,
Hmm.
and in the time being that Suru River scoring that our established TBM and PBM. So there is the
Mhm.
very hindrances here, sir. And
Mhm.
basically, I want also share that there is a basically problem is a DPR also, sir, because
Mhm.
whenever we go through the DPR, there is the huge difference between the FRL adjoining the one project and second project, sir.
Right, right.
And DPR company and consultancy from Delhi and from their headquarter create the DPR, and we can so that we resulted we uh, face their problem to match that FRL with the help of DGPS point and topo level, sir. Sir,
Mm.
thank
Mm.
you.
Yeah, thank you, Gurpreet, for sharing. I think this is what I wanted to bring at the end of my training program, that yes, such issues are very common. And why it is so? It is unfortunate that this survey is done at one point in time. The TPR takes very long time to finalize. The approval takes another duration to get done. And finally, the project execution happens after some time, after few years. The topographical conditions also keep on changing. As you are in a very challenging area of Kargil, there the topographical changes happen because of the river, snow, and so many things. Yes, the initial benchmarks finally are not available. So what is the reference? There is what is the use of that DPR? The contractor finally has to start from the scratch once again, need to create its own sort of DPR, maybe find a lot of changes. Those changing need to be incorporated in the basic design. Basic design incorporation may lead into change in the cost also. So this is all vicious circle. This is all complicated, so complicated. So that is why I mentioned initially also establishing good quality control points from the initial stage of the survey is the key. What about Survey of India benchmarks? They have spread all over India, every place. And we talk about those days when the facilities were not available, and see how difficult it was. And salute to Survey of India surveyors and engineers who have worked so hard. I have met so many directors. I'm talking about directors of present companies who were once upon a time surveyors in Survey of India. Those are the people, I'm telling you, those are the people who have worked hard. They have uh, put their efforts in establishing those points, and they have learned maximum. They have learned maximum. That is why they own good companies nowadays. They do good work even in the private sector, and they take care of such things. Such consultants, if they are preparing DPR for you, I'm sure you will be more than happy to have such DPRs from there. Otherwise, it is definitely challenging. That is why you all officers, youngsters, I believe I use youngsters because you all seems to be very young. Make sure that control points are established so strong, because we spend very little money in control points. We feel that it is temporary. We feel that it will be definitely destroyed. Because I have seen the mentality. The concrete pillar specifications are definitely good, but we don't follow finally, because we know whatever efforts we are putting in, it will not be visible after 1 year or so. So why to put efforts? Sorry, it is our mistake also. So if quality benchmark is improved, temporary benchmarks, then the survey till the project is executed, it is the same datum, it is the same benchmark which you are using from the initial survey report to the DPR to the project execution and project control. Nothing will go wrong, and you need not to repeat the work time and again, which I'm sure Gurpreet, you and your team must be repeating a lot of work. That is why you're facing a lot of problems, a lot of challenges. Cha- Really salute to you that you are still facing those issues and problems and challenges, still working in that area. However, I wish if we all learn one thing today, that we are not going to repeat such mistakes in our life, so that our future generation, our future engineers, they are not facing the similar problems what Gurpreet is facing. So let's take this as our own challenge, that whatever we learn, we try to implement the same in the field. If we don't implement whatever we learn, it is just theoretical. Okay, I can understand that this training program has got limitations, that we did not get the time to have a hands-on experience on survey instrument, but at the same time, if I have tried to incorporate certain things which you can carry with you, some learnings, some notes, some precautions, some better way, so yes, it will make a difference. Someone has to take the initiative. I'm sure our seniors have taken some initiative. I'm sure the present generation is also taking some initiative. It is our responsibility to have that practice and habit in our routine life. So coming back to the elevation or the reduced level, if they are available accurately, because level is a reference where you are leaving the reference, you are leaving the data at benchmark. If that benchmark is not available at the time of execution of the project, you don't have any reference. So how you will follow the DPR? It's impossible for sure. So let us create strong benchmarks. It is a fixed reference point of known elevation with respect to datum. As mentioned, mm, Gurpreet mentioned his problems at right moment because it relates to this particular slide only. We are talking about importance of this benchmarking. One aspect which is technical is line of collimation. It is the line joining the intersection of the crosshair of diaphragm to the optical center of the object glass or the instrument. Its continuation, it's all also known as line of sight. It is some definition, forget about it. I'll tell you the line of collimation very clearly, very easily. Let's go back to this picture. You can see, as I mentioned, that these two are different levels, right? So line of sight, what we are talking line of collimation, if it is a horizontal line, suppose these two gentlemen are of same height, not only same height, their eyes are at the same level from the ground. Consider that these two gentlemen may have different height also, but their center of their eyes, center of their eyes is at the same level from the ground. So in terms of collimation, if this gentleman, I say that diaphragm, and this, I say the optical line of the objective lens, if they are in the same line, it is the line of collimation. Okay, now I'll try to explain you the same thing on the instrument. Here, no, better here. You see on the left hand side, you can see the auto level. The diaphragm is here, the eyepiece, like this. This eyepiece is here somewhere, this side, and this is the objective lens. Now there is a marking on the diaphragm, right? Horizontal and vertical line, just like this cursor. And if it is in the same axis of the instrument, the line of collimation is correct. Now what happened, I'll tell you why this line of collimation point is important. Again, we are taking the reading, looking at here, which is a diaphragm, then this line is going straight. What happens after the some usage of the instrument in the field? Instrument is carried in the jeep or vehicle. There are vibrations. Because of that, those vibrations, generally after some time, this diaphragm because this diaphragm is mounted on the screws, they get loose. See, this is very small, almost this is the real size, and hardly say 10 millimeter size, and they are mounted directly on the screws. The size of the screws is hardly 1 millimeter. Just think that this lens is mounted on the four screws, which are hardly 1 millimeter in size. So how difficult it is for those small screws to hold it strongly while you are driving on the road. So it happens after some time they get loose. So the line of collimation goes out. Line of collimation goes out. That means your diaphragm and the optical axis are mismatching. So just to avoid that mismatching, the calibration of the instrument is done. The routine service of the instrument is done, and the line of collimation error is corrected. The important point here is, if your surveyor don't know how to check this error in the field, he might do blunders. So it is important for you to ask your surveyor or your survey consultant, if they are external agency, whether their surveyor who is working on your project know how to cross check it.
والله نازل افهم ده وده قال ايه स्टेम बचाम तो छत 10 मिनट भी नहीं लगेगा आपको
Mr. Kacho Imran, yeah, thank you. Okay, so one thing you can do, actual surveyor, don't ask anybody from the office, actual surveyor who is working on your project, please cross check. Okay, gentlemen, please show me the accuracy of the instrument. Because if the accuracy of the instrument is not controlled, the survey will not be accurate. So how to check that? I'll tell you very simple example. Maybe if I have uh, 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 directly, I do not have that, but I'll try to explain you. Okay, just listen to me. Okay, here it is. Yes, you can visualize from here that there is a red leveling staff here. Consider this left hand side leveling staff. Keep this staff say around 100 meter, or maybe you can keep it at 50 meter. Ask the surveyor to take the readings from the center. Keep the instrument in the center. Take the reading of both the staffs. In this case, fix the staff. Tie it down somewhere. One should not hold it. So tight it somewhere. Take the reading. Then from center, just move to very close to one staff, say around 2 meter. So total distance, if it is 100 meter or 50 meter, first reading is taken at the center for both the staffs. Then move the instrument near to any of the staff, which is hardly 2 meter, and take both the readings again and find out the level difference. If the level difference calculated is within say 2.5 millimeter, that means instrument is correct. If the error is more, that means instrument line of collimation has got some error. It is to be corrected in the lab. No surveyor can correct it in the field. The experts are required to do the calibration, so instrument needs to be sent to the lab or service center for recalibration purpose. So once again, let me explain you, if you have missed this point, how to check the accuracy of the auto level. Keep two leveling staff fixed at a distance of preferably 100 meter. If not available, minimum 50 meter. Then keep the auto level almost in the center. There is no need of measuring it with measuring tape. Just roughly, approximately keep it in the center. Take the reading of the two staffs find out the level difference, then move the instrument near to any one of the staff and keep the instrument say around 2 meters away from staff. Again, take the reading of both the staffs, calculate the level difference. If the level difference is more than 2.5 millimeter, that means there is an error with the instrument. The instrument needs to be sent back to the service center for recalibration, and don't use that. Okay. So this is line of collimation, because again do, I did not plan any break at this uh, point, but this is critical point. So if you have any question, you can ask me here before I proceed further, because checking the accuracy is very important. Yesterday we talked about GPS. It's difficult, but here it is very much easy. Any question? Mr. Dorje, you have any question? Mr. Dorje, do you have any? Okay, you are muted. Okay, right. You go ahead. Okay, as you could see here, this is the level sheet, field book, and here it is backside, intermediate, foresight, height of the instrument, things like that. So this slide explains what it is. Backside, it is a staff reading taken at known elevation. Backside means once you start your survey from the benchmark, the first reading is to be taken for that point. So that is the first backside reading. The survey has to start from some known points, which is your datum, which is your reference. So it is a staff reading taken at known elevation. It is the first staff reading taken after setup of instrument. As I explained you, this is your reference. Your entire survey will be based on the benchmark. So the very first backside reading is taken by keeping the leveling staff on the benchmark. Mind it, we are not keeping the instrument here. We are keeping the leveling staff on the known datum point. That is the very first reading, which is known as the backside. Now foresight. Foresight, it is the last staff reading taken denoting the shifting of the instrument. Now what I explained you, that first the leveling staff is to be kept at the known point, which is known as the backside. The leveling instrument you will keep somewhere, and then keep another staff forward in the direction where you are going to do your survey. So that is known as the foresight. The second reading of the forward staff is known as foresight. That is why forward is used, right? You know, forward gear, backward gear, reverse gear, right? So this is forward. So you are moving in the direction of the survey, which is foresight, FS. Now there is something called intermediate sight also. It is the staff reading taken on a point or a number of points whose elevation is to be determined. All staff reading between BS and FS are intermediate sight. Now, suppose you are moving in one particular direction on the road for the survey, level survey. In between also you want to know certain levels, maybe the surrounding areas, or I'll take you to the first slide again, just to explain you. And you are moving on this road. You have to reconstruct this road maybe, or some redesigning of this road. So you will move in forward direction. However, at the same time, if you want to know what is the level down to this field, so you will take readings here also. So these readings, intermediate readings, are known as intermediate levels. Okay, intermediate sites are in between readings. Change point. It is a point on which both the foresight and backsides are taken. That means wherever you are keeping the instrument, and then after taking the backside, after taking the foresight, after taking the intermediate sides also, if you have any, then you change your instrument to the next point. So this is the change point. Not very, tedious thing, just to remember. Height of the instrument, it is the elevation of line of collimation with respect to the datum. As explained earlier, the datum is basically your reference. So the reference line elevation is also known as the height of the instrument, because instrument is totally horizontal. You are taking the readings through the lenses or the telescope. It will remain horizontal. So that is why this is also known as the height of the instrument. So these are technical terms, not very relevant, but just to add. Now this is the leveling. As I explained just now, that this is the benchmark. You can see my cursor. This is the known benchmark, BM 49.873. So first reading is to be taken here, right? And the next reading, if we are taking, if we are moving in this direction, this is FS, foresight. This is okay. The first reading on benchmark, the foresight in the direction of we are moving. And in between, if you want to know the levels, these are IS in intermediate sites. Let me repeat it here. The first point here, you can see the cursor, the red colored triangle is the benchmark. So the first reading is taken here, the staff is kept here. This is known as BS. Finally, you are moving in this direction. So this is your foresight. And these are intermediate sight. Now you are moving the instrument from this to this position. This is change point. Now your this was foresight, right? This was foresight for this station. Now for this station it will become backside automatically. You will not shift this stuff. You will only change the direction. If the graduation you are watching this side, maybe you're just rotate it 180 degree, and then you are taking this reading from this side. So now this will become backside, and this next point will become the foresight. In between again, if you are taking readings, it is your intermediate side. Now come back to the first benchmark, which was 49.873. This is the known point. Okay. Then you have calculated these ground levels because this was intermediate side. This is also intermediate side, and this is the next level. So these are all on the surface are known as the reduced levels. On the ground, whatever levels you are taking with reference to a known reference point are known as the reduced levels. That is how we keep continuing the survey. I hope it is clear. Maybe if it is not clear, you can ask the question then and there, because we are moving in technical direction today. So in between also you can ask me any question if something is not clear on in relation to that particular slide. Okay. Now there are two methods of calculating the RL. One is rise and fall method. Second is the height of the instrument method. So these are all personal choices how you calculate. Rise and fall method, generally what I like, but somehow it is your personal liking, and ultimately it is the liking of the surveyor. Whichever method they want to choose, it doesn't make any difference. Now I was talking to you earlier about the changes. See, changes here it is written. Here it is 0, it is 0 plus 0.6. This is 0 plus 20, 0 plus 40, 60, 80, 1 plus 20, like that. So these are the markings marked on generally the road for road survey. So we are moving in this direction for the survey, and in this direction the height of the instrument, you see hi, these are calculated, which is converted into reduced levels. So this is again height of the instrument method, how you are using it. Every time you are calculating the height of the instrument, not at the level. Okay, height of the instrument method, again this is the simple calculation sheet. If you want, you can request me, I can send it to you. And it is not difficult also. You can also download it from Google somewhere. It is simple calculation how the levels are calculated finally. This is the back side, intermediate side, foresight, height of the instrument is calculated, and then it is converted into, on the basis of the known point, it is converted into reduced level. And these are the distances also written, that at what distance, what is the level. This is the general practice. It can be customized as per the requirement of any particular project. It is not always mandatory to maintain one kind of system. It's your choice. This is the rise and fall method, where backside, intermediate side, foresight, rise and fall is basically calculated. How much is the rise, how much is going down. So on the basis of rise and fall, also you keep doing plus minus, whatever is there. So you can calculate the uh, reduced levels. There is an arithmetic check also. Sum of the backsides minus sum of the foresight equals to sum of the rise minus sum of the fall equals to last RL minus first RL. It is very mathematical to calculate the arithmetic check if something has gone wrong or not. So these are the checks which generally surveyors apply in the field. Nothing much can be done. You can only cross check few points if you wish, on the basis of the known point, so that you know the confidence level of the surveyor, and you can create a trust. However, asking such questions is really important. So most reduced methods are presented to calculate the number of the handwritten. Rise and fall is again a method which is already explained earlier. Nothing new in this. This also I have already explained you. Now let us come back to the final outcome of the leveling. How you are going to interpret the data. How you are going to use the data, leveling data which has come to you. Now, if you consider this, if you are able to see, this is the proposed road profile. So this is the road profile. You can see the cursor. This straight line is to be the proposed road, and these points cross. These are the points which are calculated after leveling in the ground. So this is graphical representation. These are the changes and these are the numbers. So these are the points, and you have drawn the horizontal curve, horizontal line also for the proposed. Now you see these levels are above this. Proposed road level profile is this, and on the above these are the points. So it is very clear that the excavation, the cutting is to be done in this area. This cutting you can calculate, and you have the distances, so you can calculate the volume also. And if you come to this side, the level is down. The existing ground level is down. So that means this area, which is below the proposed road profile, the filling is to be done here. So we will cut from here and then fill it here. So cut and fill is the final interest point which you have. Maybe if you are subcontracting any project, so on the basis of level, you can calculate the cut and fill volume in advance, because you need to check the final bill of the contractor also. What is the cutting and filling? Generally, they calculate on the basis of the number of trucks, loaders they have provided, that so many metric ton is the cut or fill. However, you can cross check that on the basis of the level report which you have, just to ensure that uh, their billing is correct. Not only the billing, that the final cutting is not below the required cutting level also. That also you need to ensure. So these are the typical outcomes of the leveling which you will come across, and how you are going to use for the. Okay, Mr. Ajay. Mr. Ajay, can you mute yourself, please? Thank you. Okay, so we were talking about the final applications, not application, how you're going to use the leveling data uh, in your office. So this is one of the application I have explained you here. I already requested you initially that you can think of different areas of working, so that you can relate how you are going to use this leveling data, or if you had come out with some issues, some problems, I could have guided you that how you can use this today's leveling data for finding out a solution to your problem. Anyway, you need to introspect all that by yourself now on the basis of this training, whatever I could impart. So if you have any questions at this stage, before I finally wrap up the both the sessions for today's and tomorrow, in terms of learning outcomes and all that, you can ask me. Once again, not the questions. Let's now focus back to the problems and solutions.
Sir, one more question, please.
Please.
Yes. Sir, during recording of number of readings during the survey work, sir. So
Mhm.
if you did a mistake, mistakenly record one, someone reading is mistakenly, how we correct that mistakes?
Yeah, as I explained you, you come back to a particular slide. I'll show you.
Yes.
Okay, this slide. As far as auto level is concerned, you can apply these checks. You will never
Okay.
find that where was the mistake. If arithmetic checks is there, backside, sum of the backside minus sum of the foreside should be equal to,
Minus.
we have calculated this. And if
Yes.
sum of the rise and minus sum of the falls is also equal to that, that means your survey is correct.
Correct. Yes.
And finally, if you don't want intermediate, you can straight away last RL minus first RL should be same.
Same.
Yeah. If it is same, that means your survey is correct. If it is not same, I will not advise you to check where was the mistake. You reject the entire data. Ask your team to do the survey again, because
Suppose
that,
we did for a full day, sir.
yes.
Full day survey, then there might be chances of recording number of readings. So if you go for a full day, it's very difficult for us, sir. That's why.
I understand. I understand, but the basic principle of leveling or basic principle of surveying is this only. If
Yes.
you find some mistake, it has to be repeated. Because, okay, I can understand if you have 15, 20, 30 years of
Yes.
experience, and yes, you can visualize where is the chance of mistake. But it
Ye-
depends on your confidence level. If you are capable enough to find out the mistake, yes, you can go ahead with that local correction, but it is very difficult. Let me tell you, it is very difficult because
Very difficult,
we do
yes.
not know the multiple impact of that one mistake if it is continuing for other readings. So I don't advise, I never asked my team to correct the data. I always ask them to do the resurvey, which is little painful, but it will save you from a lot of things.
Yes, thank you.
Yeah, thanks.
Thank you, sir.
Welcome, welcome. Any other question? So we are left with the final 10 minutes. I offered this opportunity to all the participants if they want to comment on anything, if they want to say something who have not said so
Sir,
far.
one more,
Or
please.
yes,
During layout of a road, sir, road survey.
yes.
So how much grade we must propose in a zig turn point, sir?
Okay. This point is not related to my field because
Yes,
this is
I
a
understand. Yes.
design aspect.
Yeah,
So
exactly.
better I should not comment on this because there are so many things considered while designing. So I'm sorry, this I'm
Okay,
not the appropriate person, right person for this question.
okay, sir.
Any other problem, issue, comment?
Sir, one more, please.
Yes.
In case of backside reading, we did a mistake. How could we
Okay.
correct this? Because it's change point, na?
Yeah. If if somehow you feel that the other entire further survey was correct, so maybe you can do one thing. You can once again check the backside and calculate the foresight reduced level, and whatever difference further, whether it is plus or minus, you can apply that correction in the subsequent levels if you are sure that the mistake happened at this point only.
Okay.
Got it?
Yes, good.
Yeah. Any other question? So if nothing is more, I thank you all for listening to me. I'll
Sir,
be
one more,
grateful.
please. One more, please.
Yes, yes, yes.
Sir, in our case, we use mostly in winter time.
Uh,
So our instrument is not properly working in winter time, sir.
which instrument you're using?
Mostly dumpy levels here, it's total station like this.
No, which?
It's because of low temperature.
Okay, I'll tell you one thing. I
Yes.
do not know whether you know or not. In the total station, in most of the total station, there
Yes.
is a process of applying the temperature and pressure corrections.
Okay.
Make sure that you are applying these corrections. Always put the temperature as well as the pressure of that area wherever you are doing survey. That is number one. Number
Yes.
two, some of the instruments, at least the major companies, they provide the heater facility. That
Okay.
means if you are using the instrument below 0 degree or maybe 1 or 2 degree like that, so there is a heater facility. Switch on that heater facility. That instrument components will heat up automatically to the required level and start functioning normally.
Okay. Is that one inbuilt, sir? Inbuilt in the
Yes,
instrument?
yes, it is inbuilt in the instrument. instrument. I do not know which make you are using, total station.
Okay.
Do you remember which brand you are using?
Exactly, I don't remember.
Okay.
Maybe
Color you remember?
color the yellow. Sorry, red one.
Red one could be. I am not too sure. Pentex, it could be. But generally, you can check the functions in the menu. You can check. Generally, good brands they have heater function for sure.
Okay. Mm.
Yeah.
Even that we are facing some problem in screw jams.
The screw jams and all that I can understand. In that case, get the instrument service frequently in 3 months or so, because the quality of the grease which are used should be of good grading. Sometime if you are not using the specified grease for screws, they will definitely jam. Otherwise, if the specified grease is used as per the service standards, nothing will happen, because these instruments are checked and are made to work in sub-zero degree temperature also.
So, is there any chances to affect the bubbles? No.
Chances are always there. It depends, because bubble is also mounted on screws. They can get loose or they may get cracked. So very difficult to say that what is happening. And
Yes.
to ensure all these things, frequent servicing is required through the proper service center who are authorized and who have got all the tools and uh, lubricants for these instruments.
Yeah. Yes. Yes, sir. Thank you.
Okay. So I request all the participants to make use of these 2 training days of mine to implement in the field. Once again, if you want to come back to me with any issue later on also, these are my contact details. You can contact me uh, for any other issue, as lot of questions were asked. But if you could not ask more questions, you may come across few things maybe little later, or once you are there in the field, you might come across that yes, something was talked about in the training, but I forgot that. Still, you can contact me. There is no limitation that yes, you can contact only during the training. I'm welcoming all of you to contact me later on also for all your queries. It is a relationship which has started. I just want to contribute to your life in terms of imparting training. So you can contact me anytime. I'll feel happy to support you. So from my side, I believe it is over. And if organizers are there, maybe they can take over.
Thank you so much, sir.
Welcome.
Thank you, sir. Thank you so much.
Thanks a lot.
Thank you so much, sir.
Sarma ji, thank you very much to give your valuable time for 2 days in forenoon. I think that the participants have learned more from your lecture, and they will try to implement all those things in their project execution. And I have also listened your 2 days presentation in the forenoon also. So I think that it is very worth to all the participants. And I request to the participant, when whichever the things which Dinesh Sharma sir has told you, please try to implement all those things in your routine work at the project site. So from these words, so thank you very much to the Dinesh Sharma ji and all the participants who listen carefully during the half day session. So thank you very much. So now we are concluding 2 day session. Thank you
Thank you
very
so
much.
much.
Okay,
Thank you
namaskar.
so much, everyone. Thank you.
Thank you, sir.
Thank you, sir.